In this video, I'm going to go over a copy of the final exam preparation quiz. As you had on the midterm, you'll have some formulas. You'll be asked to agree to this honesty statement, and you'll also have some formulas. I've given you a picture of the deck of cards and then also some of the formulas that we used for probability and statistics. So let's go ahead and get started. So the first question, definition, fill in the blank with the appropriate word or phrase. A subcollection of the outcomes of an experiment is called what? And that's called an event. The sum of the probabilities of all the possible outcomes of an experiment is, it's got to be equal to 1. Now the next question I have a detailed solution for, and these are also posted for you in my courses because it needs a little more calculation. So it says the last 36 boat rentals at a boat rental company were 14 sunfish, 4 kayak, and 18 rowboats. Use this information to complete parts A through C. Part A, determine the probability the next boat rental is a sunfish. So there were 36 rentals and 14 were a sunfish. So the probability the next rental is a sunfish is going to be 14 over 36, which we can simplify to 7 over 18. The second part wants to know what's the probability that the next rental is a kayak. There were 14 kayak rentals, so 4 over 36 simplifies to 1 over 9. And finally, 18 rowboat rentals, so the probability of a rowboat would be 18 over 36, or 1/2. A card is selected at random from a deck of cards. Determine the probability that the card selected is a 3. So we know in a deck of cards we have 4 threes, 4 over 52, which we can simplify to 1 over 13. In an experiment, if there is neither a gain or a loss in the long run, the expected value is going to be 0. The owner, and this has got a detailed solution, this is an expectation question. The owner of an antique store estimates there's a 30% chance she will make $2,000 when she sells an antique china cabinet, 35% chance she'll make $1,250, and a 35% chance she will break even. Determine the expected gain or loss. So there's 3 outcomes. Make $2,000 with probability of 0.3, make $1,250, probability of 0.35, break even, which means she makes no money, probability of 0.35. And if we put those pieces together in our expectation formula, we'll come out with an expectation for her of $1,037.50. A certain game involves tossing 3 fair coins. If it pays 25 cents for 3 heads, 13 cents for 2 heads, and 8 cents for 1 head, what's a fair price to pay the game? And I have a detailed solution for this one here. So we have to look at the outcomes. There's 3 fair coins that we're going to flip, and we know by the counting principle there's going to be 8 outcomes, and I've listed those here. And there's 3 ways to win. You get 25 cents if you get 3 heads. And if we look among the 8 outcomes, there's only 1, so the probability of that is 1 over 8. We get 13 cents if we have 2 heads, and there's actually 3 outcomes rather that fit that criteria. And then 8 cents if we get 1 head, and there's also 3 of those, so the probability there is 3 out of 8. So if we put those pieces together in our expectation formula, we'll come out with an expected value of 11 cents. A list of all the possible outcomes of an experiment is called what? It's called the sample space. So we have some batteries here. Have 7 batteries. They're all the same size and equally likely to be selected. Each one is a different brand. If you select 2 at random, use the counting principle to determine how many points will be in the sample space if the batteries are selected first with replacement. So if we select with replacement, it's going to be 7 times 7 because we put back after the first draw. So we'd have 49 outcomes. If we sample without replacement, it's going to be 7 times 6, or 42. Use the counting principle to determine the answer to this question. All right, so this is a little different. A salesman packed 3 shirts and 5 ties. With 1 shirt, he could wear all 5 ties. With another shirt, he could wear 4 ties. And with a third shirt, he could only wear 3 ties. How many combinations did he have? Well, he's pretty restricted here. So we're also going to add up the different ways that he can wear his outfit. So he's got 5 with the first shirt, 4 with the second, and 3 with the third. So we come up with 5 plus 4 is 9, plus 3 gives us 12. Experiments done without replacement will result in, and the answer here is dependent events. What is the probability, and I have a detailed solution for this one, Number 13. What is the probability of getting either a diamond or a jack when drawing a single card? So here's the card deck, and we know there's 52 cards. There's 13 diamonds, if we look across the diamonds. There's four jacks, but we notice there is a jack of diamonds, so we're going to have to adjust. We're going to have to use the addition formula and subtract that 1 over 52. So 13 plus 4, 17 minus 1 is 16 over 52, which simplifies to 4 over 13. Let's see, we're on number 14. This has got a detailed solution also. If 80% of flights actually take place and cancellations are independent events, what is the probability that 3 separate flights will take place? So probability 1 takes place is 0.8. They're independent, so we're just going to multiply 0.8 times 0.8 times 0.8, and we get 0.512, and the closest answer to that is answer C. The probability of event E2 occurring, given that E1 has happened, is called what kind of probability? And that's a conditional probability. Okay, this one has a detailed solution. No, it doesn't. You do this one just by looking at it. Consider the figures to the right. Assume one number from 1 to 7 is equally likely to be selected at random. Determine the probability of selecting an odd number given a triangle was selected. Okay, so if we selected a triangle, we see there's 2 triangles there, but they're both even numbers, so this probability would be 0. I have a detailed solution for number 17. Sales representatives at a car dealership were split into 2 groups. One group used an aggressive approach to sell a car. The other one used a passive approach. The following table summarizes the records for 662 customers. If one of these customers is selected, determine the probability a passive approach was used. So out of the customers here, 308 used a passive approach out of the 662. So I put that in as a fraction, and then I simplified it to 154 over 331. And I have a detailed solution for number 18. So now we're going to do a conditional probability. If one of these customers is selected at random, determine the probability of no sale given an aggressive approach was used. So how many aggressive approaches in the table? 330. And how many of those resulted in no sale? 235. So we put 235 over 330, and we can simplify that to 47 over 66. And we have another example of this type here, and this is another conditional probability. The probability given of no sale given a passive approach was used. So how many passive approaches? 300. And how many of those were no sale? 70. So 70 over 300. We can simplify that to 7 over 30. Here's a counting principle problem. At a computer store, a customer is considering 6 different computers, 10 different monitors, 9 different printers, and 2 different scanners. Assuming each component is compatible with one another and that one of each is to be selected, determine the number of different computer systems. So we're simply going to multiply 6 times 10 times 9 times 2, and we get 1,080. An order of awards presentation has been devised for 7 people. In how many ways can the men be presented first and then the women? Okay, so let's take the men. There's 4 men. So we've got the first choice, we have 4 choices, spot 1. The next spot, we have 3, 2, 1. That's 24 ways. And then the 3 women can be put in, set up this way, 3 times 2 times 1. Each combination or each order of men can go with each group of women, so we multiply 24 times 6, and we get 144 ways. The trifecta at most racetracks consists of selecting first, second, and third place finishers in a particular race in proper order. If there are 5 entries, how many tickets must you purchase to guarantee a win? So first place, you have 5 possibilities. Second place, 4. Third place, 3. So there's 60 ways. So you would have to buy 60 tickets with all those different combinations in order to guarantee that you'll win. Okay, let's go back over here. Down here. The collection, organization, and analysis of data is called what kind of statistics? And that's called descriptive statistics. A sample that consists of a random selection of groups or units is called, and that's a cluster sample. A deck of cards is shuffled, identify the sampling technique, and a card is drawn at random. That's simply random sampling. A recent newspaper article reported on Americans' eating habits. The article stated that only about 1/3 of American adults ate 2 or more servings of fruit per day, and only 26% ate 3 or more servings. California residents ate the most, while Tennessee residents ate the most vegetables. The state in which the respondent lived in is what kind of a variable? So that's a categorical variable, puts the observations into groups. Among 50 randomly selected patients out of 302 patients admitted to an emergency room, 28% had no health insurance. Does this situation represent a sample or the population? Once you see the word randomly selected, you know you're dealing with a sample. A February 2010 Gallup poll question asked, in politics as of today, do you consider yourself a Republican, a Democrat, or an independent? 38% identified themselves as independents. Once you see the word poll, then you know that you're talking about a sample statistic. It was calculated from the sample that was gathered. Over a 4-month period, among 30 people with bipolar disorder, those given the high dose of omega-3 fats from fish oil improved more than those given a placebo. Is this an experiment or an observational study? Okay, so they're given a treatment here, so this is an experiment. A graph with observed values on the horizontal axis and frequencies on the vertical axis, and that uses bars to indicate frequency, is called what? And that's a histogram. Use the following frequency distribution to determine the modal class or classes. Remember, modal means the most frequent, and if we look there, we see the class from 16 to 20 has the most observations, so that would be the modal class. The histogram to the right shows the starting salaries for college graduates based on a random sample of recent graduates. Determine whether the following statement is true or false according to the graph. If the sample is truly representative for a group of 950 college graduates, we can expect about 70 of them to have a starting salary between $41,000 and $45,000. So that's right here. Now, if I look at the bar here, it's actually gone up into over 300. So they're saying 70, so that's not correct, because 70, it's false, because that's too few people. There's actually far more people that are in that group on that histogram. The frequency polygon to the right shows the distribution of IQ scores. Determine if the following statement is true or false according to the graph. The percent above 100 is equal to the percent below 100. Okay, so that would be the median. And if we look on the graph here, the median here is actually 115, and they're saying it's 100, so this statement is false. The piece of data that occurs most frequently is called, we just dealt with that on that modal class question, the mode. Find the mean, so I've got this over here. So number 35. So to find the mean, what are you going to do? You're going to add up all the data values. When I did that, I got 111, and there were 13 of them, so I divided by 13, and so the closest answer here is 8.5. And this one is find the median. So what do? I put them in order, ascending order, and I notice there are 1, 2, 3, 4, 5, 6, 7. So the median is going to be the middle one, which is 223. Find the mode. I like to put the data values in order because then I can see if there's multiples of the same number. And there's nothing that appears more than one time, so in this data set, there is no mode. Find the mid-range of the data set. Again, you want to put the data in order. Mid-range, you take the minimum plus the maximum and divide by 2. And so my mid-range here is 57. And let's go back over here to pick up 39. Measures of dispersion are used to indicate the spread or, and the answer to that is variability. Okay, the next question is over here to find the range. Find the range. Again, I put them in ascending order, and the range is the difference between the maximum and the minimum. And so in this case, we get a range of 15. A measure of how far, in terms of standard deviations, a given data value is from the mean is called a z-score, or what kind of score? And that is a standard score. A distribution that has a tail on the right side is said to be skewed to the right, and a distribution with a tail on the left side is said to be skewed to the left. Give an example of a skewed distribution. So remember, skew means it's going to have a long tail, so it's going to go up and then it's going to taper off either to the right or to the left. So the weights of an equal number of men and women, that would be a bimodal. The number of children in a family, rolling a die a large number of times, the number of hours studied per week. Out of these choices, the number of children in a family is the most reasonable one because most families only have 1, 2, or 3 children, and then you have fewer families that have 4, 5, 6, 7. Not everybody pays the same price for the same model of car. The figure illustrates a normal distribution for prices paid for a particular model of a new car. The mean is $24,000 and the standard deviation is $2,000. Use the 68, 95, 99.7 rule to determine the percent of buyers between 18,000 and 30,000. And if you notice, they've already done this for you on the graph, and it shows you the answer right on the graph. It's 99.7%. That was a pretty easy question because it's right in the graph, 99.7. And then I'll walk back over here for the last two, which are z-score questions. A set of data is normally distributed with a mean of 90 and a standard deviation of 12. Convert 66 to a z-score. So you're going to take 66, the data value you're interested in, minus the mean, divide by the standard deviation, and we get a z-score of -2. And then we have another z-score question. The dental index ranges from 0 to 20. The scores are normally distributed with a mean of 11 and a standard deviation of 4. Find a z-score for dental index score or dental anxiety score of 2. So 2 minus 11 is -9, divided by 4, -2.25.